first, a little bit about who I am. My name is Szajnfarber. My faculty appointment is at GW, but I also serve as the chief scientist for the Systems Engineering Research Center, which is the only DoD UARC that's about systems engineering, and it's a network of 26 universities. And so I've been giving a version of parts of this talk as what is that whole network of universities thinking about in the AI for systems space. And so that's why these slides are going to be mostly from there. At GW, I also lead a whole university initiative in trustworthy AI that has representation from every college across the university. And so again, that's part of why I'm going to talk less about the AI piece and more about how AI delivers value in society. The last thing, and this is a little bit of a, because I'm not sure how much people are aware of this, the logo that you probably don't recognize because it's about a month old, it stands for the Engineering Society of Systems Scholars, which is an evolution of CSUN, which you may have heard of, the Council of Engineering Systems Universities. We're trying right now, because we're jealous of what you guys have with the design community, to have a place for people who are more focused on the systems scholarship to get together and do some of the career mentorship. And we're also trying to solve right now you have to go to 17 conferences to talk to systems engineers, which is also why we've been having trouble as a community. So given that this is part of building the community, if you are interested in the systems side of this, we're trying really hard to bring some people together there. So with that, one of the things that we've been thinking really hard about for the last little while is what is the place for systems engineers in the AI conversation? And we decided a while ago that we're not the ones who are going to be making the next best AI. We've been framing it around two pieces: AI for systems engineering and systems engineering for AI. And I was realizing, listening to Faiz's talk, that the choice that we have that it's for instead of in is actually really important. Is that in the beginning, there were a lot of systems engineers who are also focusing a little bit more on algorithms and developing tools. But those people are now more talking to the AI communities. And the systems conversation is about the AI for and the SE for. So what does that actually mean? So on the AI side, we're taking advantage of all the AI that's been developed to help systems engineers do their jobs better. I know there are a lot of systems people here. There are also a lot of design people here. A lot of what we think about is what systems engineers need to be able to do is be able to decompose and architect systems, work with lots of different disciplines, make sure that when you put them back together, they actually work the way they're supposed to, even though people use them in ways you don't expect them to over a very long life cycle. And so a lot of those skills are about composability, or about analysis, or about making sure that things work together. And a lot of what AI can do helps do that work differently and better. We also feel like we're the discipline that makes sure that things don't break when you drive across bridges and stuff like that. And so we've been worried about how to make sure that systems work the way they're supposed to for a very long time. And a lot of what systems engineering already knows how to do has a very strong voice in the AI safety kind of a space. But there's also a need for evolution because there are some aspects of AI that are different. And so we think a lot about those kind of questions. And of course, these two aren't separate from each other because it's a good idea if you're going to use AI tools in your workflow that they work. And so we're applying some SE to AI for SC. And then there's also the notion of AI for SE can apply to SE as well. So when we think about architecture of design, we also think about architecture of workflows. And so a lot of the principles that we have in systems engineering about how to decompose systems in different ways, we're also applying to how we think about the way that we're doing our work. And so I'm going to try to give you a very broad view of all the different pieces of work that we've been doing in this space with a few examples. And then I'm also going to try to pull out some of the questions that I think that we find pretty important. And the one thing that I'll say before I do that, so these acronyms, I guess they are, AI for SE and SE for AI. We've been having a workshop for the last 6 years that started off with 20 people in a Zoom room before it was cool to talk about AI and systems engineering. This year we had to cap registration at 250 people. And that group has been a mix of industry, government, and academia over the whole time. And so a lot of the thoughts in this presentation come out of that many years of us kind of figuring out what does it mean to be a systems engineer in the AI space. Okay, so to organize how we think about different brands of what AI and systems work is doing, this is a view of the acquisition of really large complex systems in the DoD space. It's not a perfect map. We're apparently not doing this anymore as of the last little bit, but it's still a useful way to organize a lot of the pieces about what systems engineers do. And so I'm going to try to call out some examples of projects that go along in this place, and some of them I'll do a little bit of a deep dive. So a lot of what we spend our time thinking about is requirement synthesis and generating problem specifications, making sure that all your requirements work together. That's a place where it's a kind of language that has a pattern, and there's been a lot of support to do kind of analysis of those requirements, but also generating requirements and decomposing requirements, and people developing tools that do specifically that. Another thing that systems engineers do that I know designers do a lot of is analysis of alternatives, and typically analysis of alternatives has meant I know what system I want to build, and so I come up with a few others that look a little bit different and say I did an analysis of alternatives and check what we're doing. And so you guys sometimes call that more like a fixation. That's maybe fixation is a nice word for what people are doing when they come up with a set of analysis alternatives that they look at. But one of the things that you can do with generative AI, and this is a place at the conceptual stage where it matters less if it's correct, is to inspire people to think a little bit more differently about what the options are. And so people have been thinking about how do you represent that space well enough that they're good ideas that are giving people analogical basis to be thinking more creatively about what design should look like. We've also been doing a lot of work about thinking about how you would change the way that you design systems, given that you can have AI doing design. Faiz presented a view where you could imagine the whole design being done by AI. We're not really there right now, and so there's more of a sense of if you can find the right places to leverage it in the current version, does that change how you should architect systems? Some of that work comes from the idea that as crowdsourcing became a thing, there was a desire to think about how you would make systems differently if you wanted to take advantage of the power of the crowd. In many ways, the power of AI is actually kind of similar, of some very different, sometimes weird, information that you get into a process and how do you architect that way. We've also been doing a lot of work on an ontological backend to be able to generate models and design trades in a much more data-driven way. One of the big challenges in systems engineering is pulling together lots of different disciplines who frame things differently and making sure they can talk to each other. And in some ways, that's an English to English translation, but an English with one kind of tacit knowledge translation. And so how do we make sure that we can do that, and how we can track things over time as we change our designs can be really, really powerful. There's also a ton of work on test and evaluation of AI-enabled systems. You're going to hear a whole talk on that tomorrow, so I'm not going to go into a ton of it from the best person to talk about that. But some of it is just how do we continue applying all of the great work that has been done. Turns out AI systems not always that different, but some of it is really understanding where you want to be different and how you can go from testing before you deploy something to the questions that arise when now we want to be thinking about continuous monitoring. That can be really, really valuable in this setting if we're going to be able to deploy systems with active learning in them, which people see as a big opportunity. I'll do a slightly deeper dive on this one because contracting language may be less familiar to this group, but it turns out there's a lot of potential when we want to monitor the contracts to be able to use AI to support a lot of those pieces. There's also been a ton of work recently on cognitive assistance. So when we look at large trade spaces, helping people navigate data in many more dimensions than we ever were before on a conversational basis has proved to be really interesting. Again, to be able to help less experienced designers to be able to think through what that trade space means in more dimensions than you can ever represent it. And one of the interesting pieces there is that once you're already doing that, you can have just-in-time training that's customized to the kind of questions that the people are asking, which is a bit of the workforce question that we'll come back to. And then the last piece is one of the things with calls for more data is that people who make decisions are inherently limited in the attention that they can place on different things. And a lot of senior decision makers are maybe less able to look at the kind of data that you're giving them. And so we've been thinking a lot about how do you turn data into information that's useful for those decision makers? How can we use AI as an abstraction layer so that the senior decision makers can focus on the information that's most useful for them? And how do we think about that adaptively? And so that becomes really, really important when you start looking at huge projects with thousands of engineers working over many periods of time. What do you actually want to focus on? And we can do a lot when we think about how do we want to do that. All right. And so across all of these things, and this list should change every time that I make the slide, it's a little bit old, but in the kind of analytical and data processing tasks we have, there are a lot of things that AI is already really good at. Translating among concepts, developed for a lot of different languages. In systems engineering, we have both the languages of the different disciplines that we're often translating across, but we're also putting them into modeling languages that we use to be able to track across. And so maybe people don't have to spend a ton of time learning SysML anymore. That was one of the things that people said. It can also scale repetitive tasks, identify patterns. That's kind of old school machine learning, now a little bit less structured. And we have a lot of opportunities in interactive dashboards and data visualizations and things like that. But even though we want to think that AI is really good at some of the other things, the extracting meaning from data, especially when context is important, is still pretty hard. And it can be done in particular settings, but not as broadly as maybe we want it to be. Also generating artifacts. A lot of the studies that have looked at generating artifacts have seen more subtle errors than maybe you want to, and that can really matter in how you want to be using it. But to me, the more interesting thing is that when we think about how do we leverage AI in our workflows as systems engineers, a lot of these tasks that we normally think of as tasks bundle some things from the good list and some things from the medium list, and maybe even more importantly, require a lot of judgment and prioritization. And so if we really want to think about what are humans good at, what is AI good at, we probably have to think about what are the tasks and unbundling them in a different way so that we can actually do that mapping and think about the interfaces. And so if you'll forgive me some cartoons, for a long time, people always wanted to have AI replace the humans. Even if they don't say that's what they're doing, most of the presentations that you'll see is AI replacing a human task. And then some people will say, no, I'm augmenting, and so you have purple there. But I think that we have to think a lot harder about what those tasks are and thinking about tasks as a thing that we're designing and decomposing them in different way, really thinking about what we want to group. And maybe it's we break them into some nice, easy, humans are better at, machines are better at, or maybe we start thinking about layers. And so a lot of the architectures that are maybe a little bit more successful are thinking about what is a shared task where we can really scale the capacity of AI. That can make it easier to be able to decompose things in different ways. And so that's where I see as a lot of the opportunity, and also as a systems community who are thinking about large, complex, interconnected systems, rethinking about architecture in the work system has a lot of potential. So that's not to say that all the task stuff that we're doing isn't really important, but there are task level opportunities, there are workflow opportunities, and then there are system opportunities. And I'm gonna give you one example of each of these and then try to put some of these ideas together. So this is work, I don't know if he's here yet, Thailand, in the back, you'll talk later. And another group of people from Virginia Tech have been doing some of the really interesting work in this space, where they're really starting with things like artifact generation, some of the classic systems engineering artifacts, requirement documents, interface control documents. They've done all kinds of translation, text to image, image to text, all with the structured language of the different versions of SysML and other modeling languages that are important, and have been able to do some pretty cool things just at the very specific task level. They're now thinking workflow, but I'm not gonna talk at all about those kinds of pieces. But a lot of the just make our individual jobs much, much easier or better so that you can have newer people behave more like experts and iterate more quickly. Then at the workflow level, a lot of the times it isn't about what the AI can do, it's about how you want to organize your workflow. So I wanted to tell you a story about some work that we did with the contracting cadre in the Army. They had invested a lot in developing AI tools to make their jobs better. And even though the tools were working exceptionally well, they were having no impact on the bottom line of the organization because no one was using them. The first workflow that they set up was on your left here, where they had a tool that would basically look at how contractors were performing on the contract, and identify any discrepancies in things like proposed labor rates. And this was hundreds of millions of dollars across the Army, so it was like a very significant kind of thing that they were finding here that was relevant. But then what the tool would do is dump it into a spreadsheet for the contracting officers to review and then go find out what was going on. And what they were finding is that the contracting officer was never taking the next step, or sometimes it was, and sometimes they were doing it too late to actually get the money back. And so they said to us, can you make us a better tool? We're like, I don't think the tool's the problem. Let's talk about why people aren't doing this. Because in most of these applications, there is a human who's doing something. And so what we realized is that what they needed was, you probably shouldn't even call it AI, but an AI connector tool, where instead of their original tool that they'd already developed, worked really well, dumping into a spreadsheet, now instead of dumping into a spreadsheet, it could send an email to both the contractor and the contracting officer. Instead of having the contracting officer say, hey, you're doing something bad, it said, I see a discrepancy. Can you guys figure out what to do about it? And so that very much changes how the humans work together. And so a lot of what we're seeing at the workflow basis, tools are now advanced enough that we can do a ton of great things if we think about how the human relationship has changed with the AI. And so I can't tell you that it's solved all their problems. I'm sure they still have lots of problems. But just that small change with something that wasn't advancing capability has a huge impact on value generation at the workflow level. And so that's an architecture plus understanding what AI can do and can't do, and what humans can do and can't do can change things. All right. So now, what I'd love us to start thinking about more, and so far it's been more like people noticing this is happening and less being able to design it up front, is thinking about the work system level. So this is a Sankey diagram. That's a big mess, and that's kind of the point. And what it's showing is the transition from an autonomous, from old school taxi, not that old school because there's an app in the old school taxi for those of us who are old enough to think that's funny. And so it shows the transition of what people are spending time on and what the tasks and roles are in the original taxi to when you go to robo-taxi with an observer, a monitor, to when you go to fully autonomous taxi. And so I've circled two things here. We often think about this as autonomous driving being the function that's being replaced, and so I've circled the driver is supposed to be replaced by AI. And so all that you should see change, if you frame the problem that way, is now the driving function goes into the vehicle, which is what I'm circling up at the middle piece. And you should see nothing else change. And so Sankey diagrams show flows of where tasks go into other things. And so basically everything else has changed. This is important because when we talk about things like how something like the introduction of a technology and what's a complex interconnected system is going to change the function that we think it's changing, one of the things about AI is it's a cognitive role. And it turns out taxi drivers also helped you put your bags into the car, which might not matter for you, but matter if maybe you're handicapped and you'd help with putting a walker or a cane into the car. They also clean the vehicles. When there's a problem that's not anything to do with driving, they're the ones that you call. And so all of those roles needed to be put into other parts of the ecosystem of what the taxi system was. And when you start thinking about like the labor impacts, which is what this study was about, of doing something like autonomous driving, the impacts have to be measured at the system level, and the opportunities have to be measured at the system level. And so I'm not going to go into it in a ton of detail, but in that study, they looked at how there were patterns of transition and what types of roles were going to have this spreading pattern, which roles were going to be the sinks, and also kind of more importantly, what are these middle roles, because you don't want to train people to do things that are going to disappear as soon as the technology gets better. And so we need to be thinking about how do you design these transitions so that we have a path for the people who are going to be affected by it so that we know where the technology crutches are going to be. And so we've been looking at all the different ways that you can have these human AI architectures that make a big difference for how these transitions happen over time. And so I want to take a step back now, that's the system level, and talk about why that's so important for what we need to think about as a research community. So sticking with autonomous driving for a little bit, but some really simple examples. When we want to think about replacing and augmenting existing tasks, it used to be that taxi drivers earned their money by knowing the best routes through a city, and they had maps memorized in their head. And then you had Google Maps. And that would optimize pretty well and replaced one of the core expertise of what it was to be a taxi driver. But also, it was a really easy replacement for people to judge. If you're sitting in a car in a city you know and someone takes a route that you don't think makes sense at rush hour, you have a feeling about how well the algorithm is doing. And you also know if you get there, which is helpful as well to be able to judge. But you can't do that when you look at the right picture, which is a visualization of the matching market for Uber, which is now doing a system-level function that no human was ever doing. The dispatcher function was much more pair-to-pair. Now this is looking at everything. And so how would you use your expertise and your judgment to think about whether that's working correctly or not? There have been some studies after the fact that show how it's not working necessarily in alignment with our values. But thinking about that, all of the ways that we build trust in a system no longer work when you're replacing a system-level function. And so it's really important when we think about what kind of questions we're going after. I said systems engineering is a discipline that needs to be able to tell you whether you should trust the system. How we think about both how to design that transition, and also how do we evaluate whether it's working the way that we intend it to. And that's really a new kind of a problem, because almost all of the things that we know how to evaluate are in comparison to functions that we have data history on, and now we just don't. Okay, so if I think about what are 3 questions that are kind of uniquely systems-y in this AI space that I'd love to see more attention to, and there's starting to be a lot more attention to, is the first is the new architecture patterns that actually take advantage of these new technical capabilities. A lot of what we know about how to design systems is based on a very old way of organizing work, and also based on an old way of thinking about what heritage systems are and how you would actually have the subsystems that you put together to make a system. And we need to rethink this if we're going to be able to really take advantage of the AI transition. We also need new test and evaluation strategies that account for these behaviors that emerge through socio-technical interactions. Yes, we need to do lots of model checking at various levels. Yes, we need to do a lot of human and AI studies, one human and AI, but we also need to figure out how we're going to be able to do this kind of evaluation of the many humans and many AIs, and many humans of different expertise, and many different AI that are embedded into different systems in different ways. And so there's some initial thinking about that, but that's very much an unsolved problem. And then we also need tools to support the workforce transition that's going to happen, because it's a really new skill to think about supervising AI or to take guidance from AI, but also the things that people need to be able to train on, we're already eliminating a lot of the entry-level functions. And we learned some useful things through those entry-level functions, even if they weren't fun. And so there's a much more complex interaction there. And the other piece about workforce, we often think about our students as mostly professors in this room. But one of the big challenges of understanding behavior of these systems is a good chunk of the time the operators turn them off. And so we need to think about how the behavior of the system is going to be affected by the training that now has to happen much earlier in the time cycle, because that's going to affect the behavior and that's going to change the kind of system that you're developing. All right, I think we want to have some time for questions, so I'm going to skip to my last slide because it's actually a good place to do that. So from our perspective as systems engineers, we don't like to think of AI as a capability. We're really glad that some people are thinking about AI as a capability, but that's not where we think we're going to really contribute the most. But it's a critical enabler of basically everything else. And both many new capabilities at the level of impacting the warfighters, how we normally think about it, but also the overall efficiency and effectiveness of the enterprise. And money is kind of a zero-sum game in a lot of government agencies that we tend to do a lot of work with, and so that gives you more to direct resources other places if you can be more efficient in the boring back office AI functions. But in all these places, we really need to have confidence that it'll work as it should when it's really important, and without being able to tell what that's going to look like in advance. So we need to know how we want to be able to monitor for graceful failures. And so last point, just to reemphasize, there's new opportunities and new risks at many levels. Yes, we need to be thinking about AI to do particular tasks. We also need to be thinking about the individual workflow. I hope we're going to start thinking even more about system scale now, and this workforce issue is really, really an important one. We have been saying workforce is important forever, and it totally is, but it's now a part of the system that we need to think about to develop. Thank you.